is because I wanted you to make the connection about what's happening, where the cosine values come from, and what's happening as we move around the unit circle. Okay, so if you think about it, cosine is our x-coordinates. When we move around the unit circle, if we start at 0, the cosine at 0 is 1 unit because it is our x-coordinate, so it's 1 unit there. Okay, and we aren't worried about the y-coordinate because we're talking about cosine. When you go to 30 degrees, now you're not coming over quite as far in the x direction, still pretty far, but not quite as far. And so your x-coordinate is √3/2. I wanted you to visually see this. Okay, so when you're at 45 degrees, in the x direction, you're coming a shorter distance, only √2/2 units. Then at 60 degrees, in the x direction, you're only coming that unit. And look, notice at 60 degrees, that's only half a unit in the x direction. Compare that with the red line from the at 0 degrees, cosine at 0 degrees. For 60 degrees, it's only half a unit in the x direction. For 0 degrees, it's a full unit in the x direction. Okay. And then, of course, at 90 degrees, our x-coordinate is 0 because we're not going forward or backward. We have 0 distance in the x direction. So it actually falls in the opposite of the angle size. So cosine 90 is 0. Then cosine 60 is a half. Then cosine 45 is √2/2. Then cosine 30 is √3/2. And finally, cosine 0 is 1. Okay, so that's the order. It should end up being reverse order on your number line. And some of you got that, so very nice. Okay. Let's go ahead and try our next slide. Okay, solve the triangle. And remember, solving the triangle means to find all the missing information, all the angles and the sides that are missing. Okay, and so the first question when we look at this triangle is it a right triangle? And it's not. So how are we going to solve it? Well, we've got to break out our new tools that you learned about in your video notes that you watched last time. And that is, dun, 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 dun. And I'm teaching from home today for 2 reasons. One, because of the weather winter advisory, but the second is because there's a fire drill at school today. And if you're there at school, then you have to go outside when the fire drill happens. And I didn't want to lose any more class time because we're already losing class time because of the snow day. And so anyway, I'm just teaching from home, so my setup's different. So I appreciate your patience with me. Okay, so the law of sines. The law of sines tells us that the ratio of the sine of an angle is to the side opposite of it, as the ratio of the sine of another angle is to the side opposite of it, as to the ratio of the sine of the third angle is to the side opposite of it. Remember, we name our sides with the lowercase letter of the angle they are opposite. So side A is opposite angle A, side B is opposite angle B, side C is opposite angle C. Okay, also since I'm at home, I have this is my pointer, which I really like and think is super cute. Okay, so it says, don't get too wrapped up in memorizing the letters. Just remember it's the ratio of the sine of an angle and its opposite side. In fact, and this will really blow some of your minds, when you look on Delta Math, they show it as A is to sine A, as B is to sine B, as C is to sine C. And that's true because all they did in Delta Math is they put what we have in the numerator in the denominator and what we have in the denominator in the numerator. And so let me show you what this is saying. So like if we were writing, so it's always easier to think in terms of numbers. If we said 2/4 equals 1/2, you guys would agree, right? Like 2/4 simplifies to 1/2. Well, they're just saying 4/2 equals 2/1. So it is still true. 4 over 2 simplifies to 2 over 1, which is just 2. Okay, so both statements use the same numbers. We just had them in the numerator in one set and in the denominator in the other representation. So it's really not important memorizing the formula, but it's important to remember that it's the ratio of the sine of an angle is to the side opposite of it, is the ratio of the sine of an angle is to the side opposite of it. And the important thing is that you either always put the sides in the denominator or always put the sides in the numerator. In class, we're going to always put the sides in the denominator. We think that's just easiest, but in Delta Math, you'll see they do it the other way. And both ways are okay. Questions for me about that? No problem, Jisoo. Thanks for letting me know you're here. Okay, and GC, remember that the code is there in the corner, so you can join our pair deck. Okay, VFWWQM. All right, so let's use the law of sines. I know you've been waiting for it. You're like, Miss Weaver, I watched my video notes. I'm ready to go. Okay, so let's go. We want to solve for the triangle. So we have a side, but do we have the angle opposite of it? No. Wah, wah. But since we have two other angles, we totally can find the angle opposite of it. So how are we going to do that? Well, we know the triangle sum theorem from geometry, which says all triangles add to 180. So 180 minus 63 minus 38 tells me that the remaining angle is dun, 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 dun. And you're going to want calculators today, so have your calculators out. I'll pull up a calculator here to help you guys too, so that I can model using a calculator. Okay, but on this one, I got 79 degrees. Is that what you got? So that angle is 79 degrees. Now that I have an angle in the side opposite of it, I'm ready to set up my law of sines to find the missing sides. So first of all, what are the missing sides? What are we looking for? We're looking for side M, which is opposite angle M. And we're looking for side P, which is opposite angle P. Okay, so my law of sines set up, I've got to start with both an angle and the side opposite of it that I know. If I don't know an angle and the side opposite of it, I can't use law of sines, and we'll learn other tools later this unit for that. Okay, so I'm starting with the sine of 79 is to 15, the side opposite of it, as the sine of. Now, which one do you guys feel like finding first? It doesn't matter. We have to find both of them. I think I'm going to put the sine of 38, which means I'm looking for the side opposite of it. So what's opposite 38? That's going to be M. And at the same time, kind of while I'm at it, I'm going to set up my second setup as well. And let me kind of explain why. I always want to start with the original part that was given, and we kind of talked about that the other day because we don't want to amplify our round-off error. If we make a mistake in the first calculation, we don't want that to throw our second calculation, okay? So I'm still going to start with the angle on the side opposite of it that we knew. Sine of 79 is to 15. Now I'm looking for the side P. That was the other side we didn't know, which means I need the angle opposite of it, which is what? 63. That's right. So 63 is the angle opposite of P. Okay, and so I'm just showing you that one calculation is not dependent on the other at this point. We want to find the two missing sides, and we've got enough information to do that. So I'm going to cross multiply in the direction that does not have the variable and divide by the other number. Now, I always ask that you show me on paper what you're going to put in your calculator. So what I'm going to put in my calculator is 15 sine 38 divided by sine 79. Remember, the fraction bar means divide. So we're going to cross multiply and divide. And so I'm going to put that in my calculator in one step. Okay. Also, by showing on paper what you're going to put in the calculator, if you have a mistake, you can show me what you did, and I can help you find your mistake. All right. So let's put that in our calculator. Come on. All right. So keyboard's up. I'm going to do 15 trig functions sine 38, close the parentheses. Notice when you push the sign button, it automatically pops up one parenthesis, so you only have to do the closing parentheses, divided by, and it pops that all up into the numerator, sine 79. Now, if you're being lazy, you don't have to close the second one. Sine 38. And let me show you what happened here. I think it's a really good talking point. Okay, I was going to say you don't have to close that last parentheses in the bottom if you're feeling lazy, but if you want to, it's always good form to do it. Now, I got a negative answer, and my algebra eyes are always blinking. I'm like, oh no, what did I do? Should I have a negative side length for an answer? Definitely not. Okay. So when that happens, I want you to think, what's going on here? Well, I immediately realized what it is. I didn't put my calculator in degree mode. Now, I was lucky because this is a problem where it gave me a negative answer, so it got my attention. But you always want to make sure that you come to the little wrench if you're using the Desmos calculator, and make sure your mode, scroll down to the bottom. It's either radians or degrees. Radians the default, that's what it's going to be, and you have to change it to degrees. And look at that. What I love about Desmos, did you see how beautiful it was? It automatically changed my answer to match this mode. Now we're rounding to 3 decimal places all year unless we say otherwise. So that's going to round to 9.408. 9.408. So let me get my work back up here. So M is approximately 9.408. I always want you to box your answers, okay, when you're working. I know I'm not seeing a lot of your work digitally right now, but it's still good form. Okay, so when we want to solve for P, we're going to walk through that same process. We're going to cross multiply in the direction that does not have the variable, because the variable is P, that's what we're looking for, and divide by the other number. So that means P equals, and again, show me on paper what you're going to put in the calculator, 15 sine 63 divided by sine 79. Now we are in degree mode, so we shouldn't have any problems on the calculator. So let's go give that a try. Okay, I'm going to X out that one. We're doing 15 sine 63, close that parentheses, divided by sine 79. Sine 79. Okay, and what did you get? I got 13.615. If we're rounding to 3 decimal places, 13.615. So P is approximately, remember 13.6, did I say 15? Yes, 15. 15615. That looks like a B. I should fix it. Okay, so I was going to say, remember I said that wavy equal sign is just the approximate sign. It tells everybody that this is not an exact answer, but that it has round off error. Okay, questions for me on that process? Questions on how the law of sine works, or what we're going to do? You always have to have an angle on the side opposite of it to get your starting fraction. Okay. And for today, we're going to be solving for the side every time. Tomorrow, we'll use law of sines to solve for angles, which gets a little more complicated, okay? But we'll be solving for sides today. So questions about the basics of how that works. What questions can I answer? All right, so then from here on out, we're just going to take it up a notch with more problem-solving skills. So we're going to have word problems. We're going to have more complicated triangles. But it's that same basic idea. This is just one more tool that's in our toolbox now. We can still use Pythagorean theorem when we know 2 sides of a right triangle to find the third side. We can still use SOHCAHTOA for right triangle trig, but remember SOHCAHTOA is only for right triangles, okay? And now we'll have law of sines, which if we go back and look at our slide, it was kind of covered up by my presentation words down here, but it's super important. Law of sines is true for all triangles. You read it there at the bottom of the screen. Law of sines is true for all triangles, including right triangles, which means we can say the sine of 90 is to the hypotenuse as the sine of A is to A, or sine of B is to B. Okay, so that's going to be really helpful. In fact, a lot of you will start wanting to use law of sines and right triangles over SOHCAHTOA. But both are options, both are correct tools, and there's always more than one way to work a problem, which you know Ms. Weaver is crazy about that fact. Okay, so let's jump to a more complicated problem. Okay, so what do you see? What are you thinking? With all the skills that you have, what can you figure out? And how can you use it to find what they're asking for? Notice that what they're asking for here, they told us the entire side, xy, is 58. And they just want to know that little side, xw. It says solve for xw, just this little distance here. So how are we going to solve for that little side in this smaller right triangle if we only know two angles in the big triangle and a one side triangle? So what do you see? What are you thinking? Show me on your pear deck. Let's see what you got. Let's see what you got. And let me just say, if you can't figure out how you're going to finish this problem, which is totally fine and normal when you're at the beginning of a problem, see what you can figure out and see how that's helpful to you. Okay, so start working on what you can figure out and see if that's helpful to you. That's right, okay? I see Alice Fam is already working on finding that angle at the top, and that was my thought as well, okay? So if we look for that big angle here in the big triangle, we know 180 minus 29 minus 33 tells us, and Alice was right, that that big angle is 118 degrees. Okay, so that was helpful. All right, now, also if we take a look at this, okay, so now what I see, I'm like, ding, ding, ding. We only had one side and it was in this big triangle. It was in this big triangle. And in that big triangle, we now have an angle and a side opposite of it. And today is our law of sines day. So I'm like, I bet we can use that. Okay. So I know the sine of 118. Sine of 118 is to 58, the side opposite of it, but now I have choices. Okay. I can solve for either one of the remaining sides of this big triangle, but which one's going to be helpful to us? Which one should we go looking for? Thoughts or ideas? Since our goal is to find XW in that smaller triangle on the left, which side should we look for first? Okay, not the 29, and let me show you why. If we look, but I appreciate you jumping out there and giving it a spot. If I do sine 29, it's going to find the side opposite of it. So it's going to find this side, I'm going to call it R over here. It's going to find that one over there. That's not in the triangle I want. I actually want this side here, okay, this side here. So I'm going to use this angle here, and I better change that mark. That's not congruent to that other one. Okay, so I'm actually going to use the 33 because it will find me in that big yellow triangle. The 33 will get me the side opposite of 33, which is in the small triangle that I'm interested in. Remember, I'm really trying to figure out pieces of this smaller triangle. So if I use that 33, I can actually find that. So let's do that. Let's do the sine of 33. Oops, I want to keep my color coding. The sine of 33 is to the side opposite of it. I labeled it Y because it's opposite angle Y. But sometimes in pictures like this, when there's multiple sides that are opposite angle Y, sometimes you might want to pick a different letter. It's up to you. Okay, I called it Y. All right, let's get going. And I see some of you already are. That's great. Let's rock and roll. Let's solve this law of sines. Okay, so we said we're going to cross multiply in the direction that does not have the variable and divide by the other number. I want to do this in one step so that it's faster in the calculator. Okay, so I'm going to do 58 sine 33 divided by sine 118. Okay, so let's put that in our calculators and see what we get. Anybody need help with the calculator? Okay, everybody's in degree mode now. Last class, when we were doing right triangle trig, As soon as I turned you guys loose and you had to do the calculations yourself on the calculator, I started getting emails from people that were in radian mode and getting the wrong answers. Okay, make sure you're in degree mode and try some of these with us together, and that way you'll be sure you're getting the right answer. Okay, I got to keep an eye on time because we're just super short class today. Okay, we're doing fine. Anybody have that yet? No, it looks like y'all need a minute too. Okay, there. I see Ashley's got it. Ashley, what did you get there?
I got 35.777.
Which is right, and I agree. That's approximately, and she rounded to 3 decimal places, just like I've asked you to, 35.777. Okay, so y is approximately 35.777. Okay, that's still not the final answer we're looking for. What are we looking for? We're looking for xw, sorry, the measure of xw. And so we're looking for this piece here. We're looking for the measure of xw, which I'm just going to use the geometry label, which when we're talking about the measure of a line segment, we just write its letters without a bar above it. Okay, so thoughts or ideas, how we can now focus on that pink triangle on the left, the small triangle on the left, okay? Thoughts or ideas of how we can find xw. You actually have a couple of choices of how to approach it right now. I saw some of you in your pictures, you did 90 minus 29 to get the remaining angle of that small pink triangle. Okay, and so you got that that was 61 degrees. And so some of you have that this angle here is 61 degrees. That small angle at the top, that's the measure of angle, and I'll label it here to make it clear. That's the measure of angle XZW. XZW, okay, where Z is the vertex, okay? So that angle is 61 degrees. Well, if we want to use our new law of sines again, we can do that now. We know that the sine of 90, that right angle, is to the side opposite of it. And which angle is opposite? I mean, which side is opposite our 90-degree angle? Our 35.777 that we just found. Okay, because remember, to start using law of sines, you have to know an angle and the side opposite of it. Okay, so here we have an angle and the side opposite of it. So that can be our start for the law of sines. So the sine of 90 is to 35.777 as, now what do we want? Remember, we're looking for XW. So what's the angle opposite of it? That's the 61 degrees. So we can do sine of 61 is to XW. Questions on that setup? I know this is a new way for you to think about the triangle, so I want to give you a second to look at that. And I want to say, Anaf told us another correct way that we could have done it as well, okay? So let me let you look at that law of sine setup for just a second. Okay, let that kind of sink in for a second. Look at the picture, make sure that makes sense to you. Sine of 90 is to 35.77. Sine of 90. Sine of 90 is to 35.777. Is the sine of 61 is to XW. Okay, now, because it's a right triangle, Anaf remembered that we could also do right triangle trig, which is SOHCAHTOA. So relative to the 29-degree angle we already knew, if you didn't want to subtract and find the third angle, relative to that 29, we wanted the adjacent side, and we knew the hypotenuse. And which of our trig functions uses adjacent and hypotenuse? Anaf was right. That was cosine. So he just did cosine of 29 equals the adjacent side that we don't know over the hypotenuse that we do know is 35.777. Okay, so whichever way you thought of it, we should all get the same correct answer. So Anaf, you go ahead and solve your way by multiplying both sides by 35.777. While we cross multiply and divide, 35.777. Okay, while we cross multiply in the direction that does not have the variable and divide by the other number. Okay, so we're going to put in our calculators 35.777 sine 61 divided by sine 90. Now, how many of you remember the sine of 90? What's the sine of 90? Anybody? Break out your hand trick if you need to. Do you have your unit circle memorized? What's the sine of 90? You got it. It's 1. So if our denominator is 1 here, do we need to divide by it? No, it's not going to change our answer. You can put it in the calculator if you don't believe me and see if we get the same answer. But because I believe in working smarter, not harder, when I wrote sine 90, I'm like, oh, that's just 1. I don't have, if I divide by 1, I don't have to show it. So let's go to our calculator, and I'm going to do this calculation. X that out. Okay, so I'm doing 35.777 times the sine of 61. Close that parentheses. Divided by. One of these days, I'm going to figure out what's making that thing pop up for me. But for now, I'm just learning to keep shutting it. Oh, and I said I don't have to divide it. So I'm going to back it up. Okay. Now, if any of you, so I got, let's move my picture forward now. I leave the writing up there so I can see what I need to put in the calculator, but then I'll move it. So I got 31.291. Is that what you got on off? Let me look at your work here and see if I can find it. Yes. Okay. Now, he got 31.294, and I'll take a look at that in just a second. We'll put it in both ways and see. I just wanted to show everybody that if I go ahead and do divided by sine of 90, I still get 31.291. Okay, so let's try it. So if we did like on-off did and do the 35.777 times the cosine of 29. Okay, Anna, you see, I get the exact same answer, 31.291. So I think maybe you just had a little problem either with your rounding or maybe when you typed it in, because I saw you got 31.294. Either way, it should be 31.291. Do you guys see that? It's not just round off error. Okay, so sometimes there can be round off error can amplify your answer, but usually we're okay to 3 decimal places, and that's why we have you guys go to 3 decimal places, not always. And so that's why usually when we're grading your work, is we ask for 3 decimal places to make sure it'll usually be accurate at least to 2. But you can see here in my calculator, when I put that in, I got the exact same answer. So that's what I like about the Desmos calculator is it lets you go back and look at your work and you can make sure you entered it correctly. If you entered it correctly, you should have gotten the exact same thing, okay? And so I like to talk about these problems. I'm not trying to dog on you. I totally appreciate you thinking of a different way and sharing it with us. It's more, I point it out so that everybody can make sure they're using their calculators correctly, okay? So any questions for me there on that calculator usage? Very nice, guys, okay? Always more than one way to work a problem. Okay, jump in. I need to know your questions. Okay, otherwise we're going to keep going. We got a lot to do today, a lot to do. Okay, so let's go try this problem. It says solve for zy, solve for zy. Okay, so you can see zy there is the altitude of these triangles. Okay, we have triangles within triangles here. So zy is the altitude. Okay, so that's what they want us to find. So what do you see? What are you thinking? I have a side of the small triangle. I have a side of this small triangle. But I don't have the angle opposite of it. And I only have one angle in that triangle. So that's not enough to subtract to find it yet. Okay. What do you guys see? What are you thinking? I'd love for you to unmute and tell me or type it in the chat. Thoughts or ideas on getting started on this? Remember, it's not about what we ultimately want to know. It's about what we can figure out to help us get there. Okay. So tell me, what do you see? What are you thinking?
We could subtract the 50 degrees.
Excellent, Ashley.
From 180.
Yes. Okay. So she's saying we know that that linear pair has to be 180. So if we subtract 50 from 180, then what does that give us for that other angle there?
130.
Right. And that's actually the angle we want. I love that that was the first thing she thought of. That's actually the angle we want. And now we're able to use those two angles in that triangle on the left to get that angle at the top that we're interested in. Why are we interested in that angle? Because it's the angle opposite the side that we have. Remember, to use law of sines, we need an angle and the side opposite of it. Okay. So now that we've got two angles in the triangle, we can subtract from 180 to get the third angle. So 180 minus 130 minus 12, or just 50 minus 12, either way you want to do it. Okay. Gives us that remaining angle is 38 degrees. Okay. So that's going to be 38 degrees, that little sliver of an angle there at the top. Okay. Now we know all the angles and one of the sides in a triangle that is not the triangle we're interested in. So how can we use that information to get closer to the answer we want? What do you see? What are you thinking? Thoughts or ideas? And the reason I ask is because this is really just problem solving skills here. We already know the math of how to do this. So this is really just how do you figure out these problems? How do you talk yourself through it? Okay. So thoughts or ideas so far? Well, if I want this altitude in this triangle on the right, okay, it is a right triangle and I know one angle. So if I can get any other side of that triangle, I can solve for the side I'm looking for. I can solve for the measure of zy that I'm looking for. But I need at least one other side of that triangle. Well, why don't we look for the hypotenuse of that blue triangle? Because the hypotenuse is the side of the yellow triangle. So if we focus on the yellow triangle on the left first and figure out what is the hypotenuse of the triangle on the right, we can find that with law of sines. We have enough information to solve that with law of sines. We can do our setup. The sine of 38 is to the side opposite of it, which is 8.6. Remember, you have to have that much information to start law of sines and one other piece of information, whether it's an angle or a side. For today, it's going to be an angle. Tomorrow, it'll be a side. Okay. So the which angle do we want to use here? Okay, which angle do we want to use? 12 or 130? We're trying to find that side that's in common with the other triangle. Which angle do we? Yes, we want 12. Exactly right. Good job. Okay, so we're going to do the sine of 12. Okay. And we want 12 because the side opposite of it, and what should we call that? I think maybe I'll call that x because it's opposite angle x, okay, is to x. And that's why we want it, because 12 is the angle opposite the side we're interested in to help us get closer to our answer in the blue triangle. Okay, so let's find it. Let's cross multiply and divide. We're going to cross multiply in the direction that does not have the variable and divide by the other number. That gives me x equals 8.6 sine 12. Remember, we're writing on paper what we're going to put in the calculator, divided by sine 38. Questions on that algebra, on solving that? Any questions that I can answer there? All right, let's put it in our calculators. I'm going to X out that we have. We're going to do 8.6 sine 12, close the parentheses, divided by sine 38. And we get 2.904. Is that what you got? Good. Yes, yes. I see some of you already do have that. Some of you are cruising. You're not waiting for me, and that's excellent. If you think you got this, let me just keep working and let me know. Yes. Yes. Okay. And you might have named your triangle something different, your side something different than I did, and that's totally fine. Variables are just that. They're variable. You can label it whatever you want. Okay, so x is approximately 2.904. So that tells me that side is 2.904. Okay, so that's x is 2.904. And now I've got two choices of how to work this problem. So how are you going to approach it from here? We have a right triangle that we need to solve for zy. So we can use SOHCAHTOA to solve for zy. Or if we're fans of our new law of sines that we've been working on, we can use the right angle. Sine of 90 is to 2.904 as the sine of 50 is to zy. Either way will work. If you're doing right triangle trig SOHCAHTOA, the angle 50 is what we have. We want the opposite side. We have the hypotenuse. So opposite and hypotenuse would be 50, okay? So you can do it either way, either sine 50 equals the opposite that we don't know. I called it just the measure of zy over 2.904, the hypotenuse. Or you can use law of sines again and say the sine of 90 is to the side opposite of it, which is that hypotenuse we just found, 2.904. And that's what I love. It's one of the many things I love about law of sines. Law of sines is the easiest way to solve, in my opinion. Y'all are really good at cross multiplying. And if I want zy, okay, then which angle do I need? I need the one opposite of it, which is 50. So that's going to be sine of 50. Okay, and then I'll just cross multiply in the direction that does not have the variable and divide by the other number. Okay, or here, you would just multiply both sides by the denominator, 2.904. Denominators cancel, and it'll get you zy. So either way you want to do it, try that in your calculator right now, and let's see what we get. Both ways should yield the same correct answer. Both ways should yield the same correct answer. Do you guys need to see me enter it on my calculator? How are you feeling about the calculator? Let me show that one more time for people that want to see it. I'm going to do the law of sines way because that's what's new for today. Okay, so I'm doing oh, I just forgot to write out. That's why I was looking for what I'm doing. I like to write it out. Okay, so we want to show on paper what we're going to do on our calculator. So the measure of zy is going to be 2.904 sine 50. That's the cross multiplication. Divided by sine 90. That's the other thing about writing it out. Oh, and there's that denominator again. Remember we said sine of 90 is 1. So if it's sine of 90 in your denominator, you don't have to put it in, okay? But that's what I was saying about having it written out. It helps me when it's time to go to the calculator. So let's try it. 2.904 sine 50. And I don't even have to do my denominator. And I get 2.225. Is that what you got? 2.225? Yes. Yes, I love it. I'm checking y'all's work online, and multiple people already have it boxed. Yes, I love it. Y'all are doing so well. So it's approximately 2.225. Is the measure of zy. That's a really ugly zy. I can't wait till we're back in school and I can write on the board. I do much better on the board than trying to bend over and write on the, lean forward and write on the elevated computer screen. Okay, what questions can I answer about that problem? If sine 90 is 1, you're basically doing the same thing as if you were doing SOHCAHTOA. You're right, and that's why it turns out to be the same answer. Like, so on this one, you're doing yes, because this one was sine 90. Now, this is only, it was only the same on off because we were using sine in the SOHCAHTOA. You saw on the last screen when you were using cosine, it was slightly different, but I love that you're paying attention and working, okay? Sometimes they're very much the same and sometimes they're slightly different, okay? But they will, correct work will yield correct answers, okay? So very nice, okay? By the way, participating in class, thinking, making connections, it gives me something to mention and refer to when you need letters of recommendation from your math teachers for your college admissions, okay? So when you sit there silent and all I see is an icon from you, I don't really have anything to say about what kind of a student you are. But if you're asking questions and making connections and thinking deeper, then those are things that I can mention when I get asked to do college admissions recommendations. Certain programs, certain schools always want to hear from a math teacher. And so I usually get asked to do a lot of those. Okay. Let's try another problem. "10 minutes to do a word problem." Let's see if we can get through at least this. Okay, and so people are messaging about tech problems and stuff like that. I am going to post a video of today's class, so I will post that in our webpage. I don't always do it, but I will today for sure because I know so many people are having issues. I love watching you guys network. I see some of you guys are drawing your picture and figuring things out. I love it. I love it. Okay. All right. It says the highest bridge in the world, and this is actually a picture of it. True story. Okay, the highest bridge in the world is the bridge over the Royal Gorge of the Arkansas River in Colorado. Sightings to the same point at water level directly under the bridge are taken from each side of the 880-foot-long bridge. Okay, let's process the information that we just got there. The bridge is 880 feet long. 880 feet long. Yellow works great to write on here. It'll show. Other colors do as well, but just so you know, 80 feet. Okay, so it says from either side of the bridge, they're making sightings to the same point on the water. Okay, oops, that is such a mess. Let me undo that. Okay, so from this side to a point on the water, so that angle, and what do we call that angle, guys? From a horizontal down, that's an angle of depression. You got it. Thanks, Gia. I should have given you more time to say it. Very nice. That's an angle of depression. So we've got an angle of depression there. And from the other side to that same point on the water, we have another angle of depression. And that one is, okay, so one is 65.5 and one is 69.2. So 69.2 and 65.5. Okay, and I'm going to erase a little bit because it's kind of small in that triangle. I'm going to erase my little angle of depression arrows. But I was like, ooh, a good example of angle of depression. Okay, so we got 69.2 and 65.5. How high is the bridge? Dun, dun, dun. With that information, we actually can figure how high is the bridge, okay? This indirect measurement is used all the time in the real world. That's how they figure out how tall mountains are. That's how they figure out how far away the sun is. That's how they do all kinds of real world measurements, okay? And so let's see if we can find it. So if we want the height of the bridge, we're going to drop an altitude perpendicular to the one side that we know, okay? So I'm going to drop that altitude in there. It's kind of messy. Go ahead and make it a solid line. That'll look better. Okay, and that's what we want to know is how high is the bridge. Now, height is always measured perpendicular to the horizontal, so I know that will form a right angle, which will split this into two right angles, okay? And so thoughts or ideas on how we can go about solving for that, okay? What do you see? What are you thinking? What can we figure out now that'll help us get closer to what we want to know? Thoughts or ideas? Okay, I notice we only know one side of the triangle. Do we know the angle opposite of it? So the angle opposite that 880 is this big angle. Okay, it's this big angle. Do we know that angle? No. Can we find that angle? Can we find that angle? You bet we can, okay? If we focus on the big triangle here, if we focus on the big triangle, we know two of the angles, so we can find the third angle by subtracting from 180. So 180 minus the 69.2 minus the 65.5 gives us that third angle is, we got to step it up a notch. Okay, 45.3 degrees. Is that what you got? 45.3 degrees. Okay. Now, how is that helpful to us? Well, because now we have an angle on the side opposite of it. So we can start the law of sines. The sine of 45.3 is to the side opposite of it, 880. Remember, that was the only side we knew, as what is to what. Now be careful here. 45.3 and 880 are both in the big triangle. So the only sides we can find right now are sides in the big triangle. Okay, you've got to be in the same big triangle. Okay, so which angle do you want to use and what side will that help you find? And there's not one right answer here. We can actually look for either of the remaining sides and use it to help us find it. Okay, so anybody have a preference? I'm at home, so I don't have my seating charts to call on you guys. Okay, Ella says the one on the left. Let's do that. Okay, so Ella wants the one on the left, the one of 69.2. So I'm going to do the sine of 69.2. Okay, so if I use 69.2, this angle here, what side is that going to find? It's going to find the side opposite of it in the big triangle. I'm going to label it Y because we've already used an X, okay? So it's going to find Y in the big triangle, okay? It's going to find the side opposite of it in the big triangle, so I'm going to call that Y. All right, let's cross multiply and divide. We should be getting pretty good at this by this point, okay? So Y equals 880 sine 69.2. That's my cross multiply. Divided by sine, 45.3. See, and this is like the math I love. I'm like, let's start problem solving. Let's start figuring stuff out. Okay, it's super fun. Okay, all right, let's put that in our calculator and see what we get. 880 sine 69.2 divided by sine 45.3. Alice Pham already has it. She's a superstar over there. I'm going to have to put it in my calculator because I actually, when I worked it on my answer key, I worked the other one. So I'm going to put it in the calculator and check and see if Alice is right. Okay, so let's put that in our calculator. So I'm doing 880 sine 69.2. Close that parentheses. Divided by 45 sine of 45.3. That's the thing, because there's more than one way to work a problem. The way, and I double typed my 5. I got to go back and fix that 45.3. The way I think to solve it, the work I show on my answer key might be slightly different than yours. But if we do correct work, we should get the same correct final answer. Okay, so I got 1,157.354 here, which is what Alice did have. So good work, ma'am. Okay, so we agree. So Y is approximately 1,157.354. Okay, so we're so close, guys. This gives us this side over here. Y is approximately 1,157.354. Okay, how is that helpful to us? Okay, I said we're close. Can you see it? How are we close? Okay, we're close enough that we can change our focus on the triangles now. Okay, we can now zoom in on this small right triangle on the right, on the small right triangle on the right. We now know that the hypotenuse of that right triangle is 1,157.354, and we want to know x. And there's a couple different ways we can find it, okay? So what do you see? What are you thinking, okay? Which approach do you want to take? Do we want to switch and use SOHCAHTOA since it's a right triangle? Do we want to keep using law of sines because it's the function of the day? What do you guys want to do? Which way would you like me to show solving it? SOHCAHTOA or law of sines? Both will give us the same correct answer. Okay, Ella requests law of sines, so let's do it. Okay, so we're going to use, look at our law of sines setup here. Okay, in this triangle, we have to have an angle on the side opposite of it to start. The only side we know in that pink triangle is the 1157.354 that we just found. So if that's the side I have to use, 1157.354, what's the angle opposite of it? What's the angle opposite of that? It's our right angle there in the corner. It's the sine of 90. Okay? So sine of 90 is 1157.354 as, now I want x. I want that height of the bridge. Okay? So what's the angle opposite of our x? The angle opposite of it is the 65.5. Now, like I said, there's always more than one way to work a problem. You could have subtracted 90 and 65.5 from 180 and gotten that small little angle piece at the top, and then you could have used it. Okay, so there's always more than one way to work a problem. But if you cross multiply and divide at this point, okay, so x equals 1157.354 times the sine of 65.5 divided by sine of 90. But of course, we've mentioned a few times the sine of 90 is 1. And so if you're dividing by 1, that doesn't change your answer. Okay, so you really can just put the top part in our calculator. Okay. So let's give you a second to do that. And what do we get? Yes, I got 1,053.147. And our units, we always need units for word problems. That's the height of the bridge in feet. So coming in at just over 1,000 feet tall, that's the height of the bridge. Highest bridge in the world over the Arkansas River in Colorado. See, why is the Arkansas River in Colorado? And I can tell you, I used to live in Texas. The Colorado River empties into Texas. So we used to go skiing on the Colorado River when I lived at the Texas coast, because that's where it comes out. Anyway, okay, that's pretty much all we have time for today. We've only got like a few seconds left of class. Questions I can answer. You could have used the other triangle. Okay, in my work, I used the other triangle, and I got that the left side of the big triangle was 1,126.571. And when I plugged that in to solve for x, I still got 1,053.147 as the final answer. So you'll have different work along the way if you pick the right triangle versus the left triangle, but correct work always leads to correct answers. You guys do your Delta math and watch your video notes for next time. Okay. Have a good day. That's my bell for the end of class. Perfect timing, perfect timing. Y'all have a good day.